video, guys, we're gonna talk about Bernoulli's equation. So if you ever seen it already, it is in the form pressure over rho g plus z1, the elevation, plus b squared over 2g, and it says these parameters are all equal to constant. So that means whichever point you are in a flow, especially on a pipe flowing flow, if you choose 2 points, then these three parameters will always be the same wherever point you are going to analyze. So basically, the terms here are just the pressure, potential energy, and kinetic energy. So if you think about it, since work and energy are related to each other, and furthermore, energy is the ability to do work, then the work done by the pressure and the potential energy and kinetic energy is what Bernoulli's equation is all about. So if we start with the definition of pressure, we know that pressure is equal to force over area, or the amount of force you distribute over an area. So that's a pressure. And then for potential energy, you know the formula for potential energy is mass times the acceleration due to gravity and the height. In other words, it's the force over a height, or it's a force times the height, or it could be weight, since mg is a weight times height. So it depends upon the elevation you are in, or the elevation of the fluid. That's the potential energy. The higher you go, the higher the fluid goes, the more potential energy it will possess. And then whenever there is a motion, when that potential energy are released, it will be converted, some of the energies will be converted into kinetic energy. So that's why we have this term right here. A moving fluid has a kinetic energy 1/2 mv squared. So we said that that is equal to a constant. Now if we think about the pressure doing work, we know that Fd is the formula for work. So how are we going to rearrange this force over area to form Fd? So it's simple, right? We just have to multiply it by A and then times D. Because as you can see, the A's here will cancel, leaving us the work formula. But we're not gonna cancel that A. Just use that to manipulate it. And then the terms here will be as is, will be the same. Nothing will change here. Equals constant again. Now, what is force over area times the D, or the height of the fluid? So AD here, as you can see with this drawing here, is basically the volume, right? So if we change this F over A as what we call pressure, and then AD as volume of the fluid moving, then we can say that let's move this first. We know that density is equal to mass over volume. If we solve for volume here, isolate volume on one side, we can get mass over density, right? So it's just a cross multiplication, mass over density. And if we replace this term, the volume, with mass over density, we're gonna get pressure times mass over density. And now we have this equation equals a constant. Since we know that the mass of the fluid, by law of conservation of mass, by that law, if we follow that, the mass will not change all throughout the flow. Therefore, we can just cancel out this mass term here, all of this, and also for this right side. So now we're gonna left with pressure over density plus GH plus 1/2 B squared. So if we divide this one by the acceleration to gravity, we're gonna get P over rho G plus, we're gonna divide this by acceleration due to gravity, so we're gonna left only with H plus acceleration due to gravity. So it's gonna be V squared over 2G equals a constant. Alright, so now here's where this formula came from, where H here is the elevation Z1. So we just refer it as Z because H sometimes on Bernoulli's equation refers to head loss, head due to pump, or it could be head due to turbine. So we use another variable Z1 to distinguish it from one another. Alright? So that's basically where this Bernoulli's formula came from. It's the work done by the pressure, potential energy, and the movement or the kinetic energy of the fluid flowing full through a pipe. Right? So for instance, to give you an example, if we have here point 1 and here point 2, if we assume no head loss, because the extended version of Bernoulli's equation between 2 points is of the form this one, P1 over rho g plus Z1 plus B1 squared over 2G plus head of the pump. If you add energy to the system, so that's due to pump, most commonly due to pump, it's gonna be equal to pressure at the second point, and then the elevation at the second point, the kinetic energy at the second point, and then plus the head due to turbine, because turbine extract energy and convert it to electricity. So it's going to be another form of negative head, or in other words head loss, and then head loss. So these losses are due to major and minor, and that major is due to friction in the interior walls of the pipes. So as the fluid moves, some of the particles that's near the walls of the pipes will get trapped, or sometimes moves slow compared to the center of the pipe. So that's because of mainly friction due to the pipe. So that's the major losses. And then for minor losses, it could be due to pipe fittings, bends on the pipe, the sudden expansion and contraction of pipes, and many more. So that's head losses. So this is basically the extended version of Bernoulli's equation. It came from the idea of law of conservation of energy. So the energy that is from the source must also be the energy at the end, or at the point where you are analyzing it. So that's it for this introduction, and I hope I can make more videos and examples for this particular topic. Thanks for watching. Peace out.